Hi folks, welcome back to 11.1 sequences and their notation. And in this video, we're going to take a look at some more examples. So let's get started. Example 2, consider the formula. A sub 1 equals 1, A sub 2 equals 2, A sub n equals 3, A sub n minus 1 plus 4, A sub n minus 2 for all n greater than 3. All right, so first question here. Is this formula recursive or explicit? And how do you know? All right, so being able to tell the difference here is important. And I hope by comparing this to the examples in the previous video, we can say that this formula is recursive since we are given some starting terms and then what to do with those terms, okay? Since we are given starting terms and what to do with them. Okay, so what I mean by what to do with them is I just plug in n for 3, 4, 5, 6, 7, 8, 9, and that'll help me find all of the terms. Okay, so part B says determine the first 5 terms of the sequence. That means that I want to find A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. So the first 5, kind of like that would be in the Fibonacci sequence, it would be like these 5 numbers. I want to find out what those first 5 numbers are. Okay, so let's take a look. A sub 1, well, are we given A sub 1? Usually for the recursive, we are given at least A sub 1, okay? And so we know from looking above that A sub 1 is 1. A sub 2, if we look above, is 2. So we actually have 2 of the 5 terms we need to find already. For A sub 3, we need to plug it into this formula, okay? So everywhere that I see an n, I'm going to plug in 3, okay? So A sub n equals 3, A sub 3 minus 1 plus 4 A sub 3 minus 2, okay? Now, here's how we simplify from here, okay? We get 3 A sub 2 plus 4, and let's see, 3 minus 2 is 1, so 4 A sub 1. What does that mean for us? Well, it means we get to take our A sub 1, which is 1, and plug it in there. And it means we get to take our A sub 2, which happens to be 2, and plug in that number. So what does that give us? Well, that gives us 3 times 2 plus 4 times 1. We can do a little arithmetic here. 6 plus 4 gives us 10. Okay, so that, my friends, is how we use the formula. But let's go ahead and find A sub 4 and A sub 5, get a little bit more practice. So A sub 4 is 3 A sub 4 minus 1 plus 4 A sub 4 minus 2. And if we simplify that, that's 3 times A sub 3 plus 4 times A sub 2. So now my A sub 2, okay, that's going to go here. And my A sub 3, which was 10, is going to replace A sub 3, okay? So we get 3 times 10 plus 4 times 2. Let's see, and that gives us a total of 38 for a sub 4. Okay. All right, we got to do this one more time to find a sub 5. A sub 5 equals 3 a sub 5 minus 1 plus 4 a sub 5 minus 2, which is 3 a sub 4 plus 4 a sub 3. And if I go back to my colors, I see that I have an a sub 3 in here. So everywhere I see the a sub 3, I can put a 10. And everywhere I see the a sub 4, I can put a 38. So 3 times 38 plus 4 times 10. All right, let's think about this a little bit. So 3 times 38 is 114 plus 4 times 10 is 40. So we add these together, 154. That is my a sub 5. Okay, so the way we use these formulas, we got to be really thoughtful about what n means. Remember, n tells us which term we're looking for. That's where we plug in the numbers. And when you were showing your work in your quiz, right, showing all your calculations and where you got your numbers would be really valuable. All right, let's try another example. So consider the formula a sub 1 equals 9, a sub n equals 3, a sub n minus 1 minus 20 for n greater than 2. So this looks a little bit different than the first two examples we've seen because we only have one starting term. That's the only term we need. Everything after that, we plug it into this formula, okay? But since we have a starting term, okay, we can say that this formula is recursive since we are given a starting term and formula to find next terms. Okay. So one thing about this formula I want to point out, in order to find any term, I need to know the one that came before. So if I want to find the 1000th term, I better have the 999th term. Okay. All right, let's go ahead and find out what the first 4 terms are. So a sub 1, according to our starting value here, we get is 9, right? That is our starting value. In fact, let's go ahead and highlight that because we might need this in the very next one. All right, a sub 2 is 3 a sub 2 minus 1 minus 20. That is 3 a sub 1 minus 20. Oh, check it out. We do need that a sub 1, right? So everywhere we use the a sub 1, we're going to plug in a 9. So 3 times 9 minus 20 is 27 minus 20 gives us 7. Okay. That means that our a sub 2 is 7. All right, a sub 3 is 3 a sub 3 minus 1 minus 20, which gives us 3 a sub 2 minus 20. So this time I'm not going to do 3 times 7 minus 20, but now I'm going to, or 3 times 9, but now I'm going to do 3 times 7 minus 20. So 21 minus 20 gives us 1. All right, this is our a sub 3. We got to find a sub 4. 3 times 4 minus 1 minus 20. And that gives us 3 a sub 3 minus 20. And so we're going to go ahead and plug in 3 times 1 minus 20. So 3 times 1 minus 20. 3 minus 20 gives us negative 17. Now this gives us our a sub 4. We could use this to find a sub 5. And once we find a sub 5, we could use that to find a sub 6, and then use that to find a sub 7, okay? So it is recursive in the sense that we need to know the one that came before in order to find the one that's coming next, okay? All right, my friends, we're going to stop here for this video. Come on back in the next video as we start to explore what the graphs look like for us here, okay? All right, see you back here.